Thank you, Dr. Pedamallu, for that very interesting talk. So, our audience has quite a few questions, and we'd love it if you could answer a few of them. So, to start off, one of the questions we had was to compare the terms deep learning with machine learning. These terms get used interchangeably a lot in the literature and in the internet when we read about it. So, are they the same? Are they different? Because we have a diverse audience here, it would be nice to get your perspective on this.
Yeah, thank you, Kaushik. So I think the deep learning versus machine learning. Deep learning is a subset of machine learning, I would call it as, and it's part of the machine learning. So often machine learning is the one that we normally use the traditional statistical approaches to model it. So it can be regression, it can so on and so forth. Whereas a deep learning normally they uses the artificial neural network, where we have multiple layers, which are interconnected layers that you have it. And also coming to the data requirement that you have it is machine learning algorithms often requires small to medium scale of data, whereas a deep learning requires a lot more data, a large scale of data. Whereas if you look at even feature engineering between deep learning and machine learning, you need to do a manual feature extraction. Whereas a deep learning, there is an automatic extraction of features that is available for you. In terms of the performance that you see it between the deep learning and machine learning that you have it is like, whenever you have a complex data that you have it, always deep learning outperforms machine learning. But the other side of the table is that if you look at the interpretability of the machine learning versus deep learning, machine learning is a simple compared with the deep learning ones, which we have like, more advanced neural network models that you have it. So interpretability, if we look at it like, machine learning is easy to interpret, whereas the deep learning is a little bit complex as it is. And I would say like, generally for a smaller application, smaller data that you have it, simpler data that you have it, we normally go for machine learning models and deep learning models for that. So machine learning algorithms normally used for predictive modeling or clustering or classification tasks, whereas the deep learning models that you are seeing like, more suitable for image processing or speech recognition or natural language processing and so on and so forth. So this is the kind of like, if you look at a very high level AI, which is an artificial intelligence, which is machine learning is part of AI, DL, which is the deep learning, is part of the machine learning. That's how we can classify it. And they have their own strengths, weaknesses, I would call it as. Normally, deep learning requires a lot more compute power compared to the machine learning. I hope that answers the question.
Thank you. My next question is on performance, since you mentioned that. So, if you're a beginner in this field, what kind of hardware would you want to run these kind of calculations? And given the engineering effort going on, have you noticed any kind of specific hardware that works better for this kind of approach?
Yeah, very good question. I think in terms of the compute infrastructure, right? So there is a lot of advancement that happened in the compute infrastructure also that helps to implement these algorithms. So one place which I normally go is that I develop all my models in AWS or GCP. So where I can lend the resources as I look at the data and look at these the problem that I'm trying to solve. So if you take the deep learning, for sure, the computing infrastructure that you need will be more intensive, I'd say. Like, it can be like, a GPU assisted infrastructure will also help them to converge much, much faster there. So I would say like, based on the problem that you're solving, the infrastructure varies. And if you're doing an image processing type of problem solving, then I would really go for a very high-end machines to work it on. So to go to the level of what is that the specification of the instrument, it is always hard to say because it always depends upon the problem that we are trying to solve or what kind of area that you're trying to solve the problem from. So I hope I answered part of it. So
Thank you, Dr. Pedamallu. My next question is noise in medical images, say radiological or otherwise. So this is a problem, and I think it's a widespread problem also. So some of the data sets people do get, even in terms of reference images, they can sometimes be really noisy. So in terms of training a AI model or a ML based model, how does noise factor into the equation, and how do we deal with that?
So that's the step that we normally do it at the image pre-processing step, because you're on the question is on the point, because that's the biggest problem that people face it. At least, like, if you look at the data that has been generated a few years back, it is much noisier when compared with what we have it now. There is an advancement even in the biomedical imaging that's happening. So that's the place where, like, in the image pre-processing step, that's the place where we try to denoise the images that you have it. So there are algorithms that we can use it for doing that one. Unfortunately, I'm blanking out the name of those algorithms. I will be happy to share with them in the LinkedIn post, so I can do that. So for that.
Thank you, Dr. Pedamallu. My next question has to do with how do you choose which is the algorithm for your particular application? Because um, I myself sometimes read up on these topics, and sometimes there is some really generic advice like when in doubt, go for CNN over DNN. That's something, it's all you might find that in the web quite a lot, but why would that be?
Right. So I think that's a very, very interesting question, to be honest, and also valuable question, I would say. So once again, as you rightly mentioned, which is the model that is needed for a given data type or data that you are using it, right? So in case of I would say CT scans, I saw, like, CNN models work pretty well. And you have it also depends upon what is the data modality that you are using it, or image modality you are using it. So normally we say DNNs are better than CNNs, but nobody tells really why. The main reason for not giving you the prescription is that it once again depends upon what is the image modality that you are using it. If the image modality versus how much noise that image modality can bring it to the table dictates what model you're trying to use it. So that's always goes hand in hand with each other. So that's the reason why a given we cannot give you a right away prescription saying that yes, CNN is always better than DNN or vice versa. So there is transfer learning models that are much better nowadays, which can perform much better than other ones. So I think I would say, like, it's a combination. So people also use ensemble approaches, using multiple types of models together, and then identify the ones that performs much better. So there is a lot of thought process for selecting models for the right data that you have it in your hand. So that is always based on the modality of the data type that you're using it. I did not give you a prescription for sure, but it's always skewed to the modality and the noise of data that you are using it, and the amount of the data that you have it in.
Thank you, Dr. Pedamallu. The next question is, are there any demonstrated applications of real-time AI being applied to, the AI gives you your input as you are taking the images?
So the AI giving the input, and we getting the output from the AI. So for example, if we go back with my slides, I would say, so I think there is a tool called Sybil that has been used for this is a new AI tool, but I would say, as I mentioned, right, that's one of the challenges that we are facing, is that we always have these AI/ML approaches that can do a retrospective analysis. In the real time, there are very few that we can see it, but in the recent time, the FDA has approved more than close to 250 different devices that are enabled with AI. There is a CT scan that has been enabled with AI that helps and assists the radiologist to understand the image and knowing whether this is a benign or a malignant. So there is, like, this is the paper where we can go and find the list of the devices. I don't remember top of my head what is the names of those devices, but yes, there's a list of devices that are now currently used, also some of them in the field to do this. But how much we are embracing it to use it in the real time is always depends upon the radiologist that is going to use these devices.
As an add-on, can
An
any
add-on.
of these approaches be used for, say, intra-operative guidance?
So intraoperative guidance, it means for surgical intraoperative guidance. What do you mean?
Yes.
Yeah, I think people have it, but how much used in the real surgical room is always a debatable thing. It always depends upon who is the surgeon that performs these ones. There are people who are tech savvy, people who uses it, especially, for example, if you take brain cancer. It is always better to have some assistance, right? They are always being very, I would say, not conservative, they're more aggressive to remove the tumor. They don't want, because they can only do one operation, I would say, they cannot operate on the same person multiple times. So, but AML approaches can help them, can assist them, but it once again depends upon the surgeon and his acceptance towards this technology.
Thank you, Dr. Pedamallu. So there's a thing called overfitting when it comes to machine learning or any mathematical model, in fact. Can you comment on whether this is a problem in the context of machine learning models and uh, how to handle it if it is?
Yeah, so that's why I was when I was speaking about the training data that is needed for building your models, not only volume makes sense, it will also diversity. So if you're having same kind of data, same kind of image, like you have 10,000 images like that, the model that you're getting is overtrained towards that image, not really having the diversity that you see. So when you're picking up, when you're selecting this training data, make sure that you have the diversity as well as the volume together. Same time, you want to also see the quality of the data and also the images that are having good resolution. Same time, you want to mix with the bad resolution images also into that, so that the model will have more realistic training that is going to happen. Then whatever predictions that comes out of it will be very helpful. If we are having a very nice data with no diversity, just like the same type of images, there are thousands of images, then the problem will be like an overfitting to a particular kind of it, then the models turns to be not very good.
Thank you. There's a question regarding false positives and false negatives which do occur. So could you comment on these and how AI can help in these cases?
Yeah, so I think that's why I say, like, it can, there are false positives, false negatives, even with AIML. There is no doubt about it. That's the reason why you never achieve, like, even we say 100% accuracy. Sometimes if you go into the real-time scenario, there will be 1 in a million cases you may have a false positive and also a false negative. But the detection, the error rate is so small in that case. And for example, when you compare with a human versus a machine that has been trained on a diversified, a large volume of data, then I think I would say is that the AML approaches can be better. But I'm not saying that the approaches will do everything on its own, but I need that radiologist to finally say, yes, it makes sense. So I don't want to replace the radiologist completely from the game, but yes, the false positives, false negatives also depend on how much data you're using to train your model, and what is the diversity of your data that you're using to train your model.
Thank you, Doctor. There's a question on whether there are any public data sets available for related to osteoarthritis, and if there are any works you are aware of for progress made for in this aspect using AI or machine learning based approaches.
So I'll be happy to connect with that with the question that is sent with the individual who sent that question, because I don't remember it off my head. I'll be happy to point to certain things after the seminar. I'll be happy to do that. They can connect with me on my LinkedIn, or they can send to the email that has been there in the last slide that I have showed. So let me put that slide. So yeah.
So, as our last question, we'd like to ask you, what is the future outlook for widespread and mainstream acceptance of AI and ML based approaches for imaging diagnosis in the upcoming years?
Yeah, it's a great question. So I think one thing that we need to make sure is that there is an acceptance that is coming from the radiologists as well as clinicians for these approaches is a very important thing. How do we do that? One is that we may have to give more, more seminars like this and help them to understand the powerfulness of AI/ML. But at the same time, we should also provide the guarantee to them saying that it's not going to replace you guys. It is only going to assist you. When we talk about AI/ML, 100% detection rate, 100% prediction rate, all these things, as an individual, I'll be thinking like, okay, fine, tomorrow I'll be replaced with an AI/ML approach, which is not going to be true, because it's going to only help us to make things better. So one thing we need to also do is that there should be an awareness to be created saying that having this technology can reduce that burden on you. That is the way, that is the carrot that helps it to be accepted. Same time as we see the biomedical imaging area as well as AI/ML approaches, there is a lot of advancements that are happening every day. So with that advancements, with the acceptance from the clinicians and radiologists, that can do wonders in the clinic. And also we can also make them to know that it is not for replacing, it is only assisting. The moment we make this message consistent to them, I think they will accept it. And then it will help the patient at the end of the day, and the patient will get better much faster.
Professor Dr. Pedamallu and Dr. Kaushik Natarajan for that wonderfully moderated live Q&A. I think there's still questions that remain, and as Dr. Pedamallu has mentioned their email ID, I think please do connect with him on LinkedIn and share. If you have more questions, reach out to him via the email ID. I'm sure he'll be happy to kind of take those questions up. With that, this brings us to the end of today's session. We hope that you have enjoyed this broadcast. We invite you to view the edited recordings from the past events in the ACS Science Talks library. At the end of the session, you will receive a brief survey. Kindly share your feedback with us so that we can continue to improve and serve you better. The link for the survey is already placed in the chat, so please, whoever is live right now, please do click on the link and do fill out the survey for us. And on behalf of all of us at ACS, thank you for joining us today. We hope to see you again soon for more ACS events. Until then, stay safe and healthy.